When solving this triangle right here, you can't use the law of sines because you don't have an angle and its opposite side. But what you can do is use the law of cosines. And the law of cosines says that if you want to find a, we write a squared is equal to, and it's b squared plus c squared. B squared plus c squared. Looks familiar, doesn't it? Almost looks like the Pythagorean theorem. However, there's a slight change. Minus, and we take 2 times b times c, and then times the cosine of angle A. Looks like a lot, doesn't it? I mean, it starts off as the law of, starts off kind of like the Pythagorean theorem, but then you got that subtraction piece there. And we have to write it 3 different ways. So this is the first way. The second way is b squared. And anybody know what's going to come next if I'm trying to solve b squared? Anybody know what these two are going to be? A squared plus c squared. Minus 2 times, do you know the next two things? 2 times AC. And then times the cosine of, do you know what angle it's going to be then? Angle B, good. And then the third way we write it is actually the most common way that it's expressed. C squared is equal to A squared plus B squared. Again, looks just like the Pythagorean theorem. But it's not the Pythagorean theorem because it's not a right triangle. So to account for the fact it's not a right triangle, minus 2 what? AB. Then cosine of C. Good. So I want to find A here, so I'm going to use the A squared is equal to B squared plus C squared minus 2BC cosine of A. So I write A squared is equal to B squared, that will be 12 squared, plus C squared, that will be 15 squared, minus 2 times 12 times 15 times the cosine of 26. And that looks like a lot of work, but fortunately, if you have a scientific calculator, I think just about all of them nowadays should do this. It used to be that that wasn't the case. But if you have a Texas Instruments calculator or a TI-8384, you should just be able to type it all in. So I encourage you to try that, typing it all in right now to see if you get what I have right here. And I don't know if it works that way on your phone or not, if you're trying to use your phone. But you just do 12 squared plus 15 squared, and then minus 2 times 12 times 15 times the cosine of 26. And I get 45.43. So that means A squared is 45.43. So now what? Yep, square root. And I get 6.74. So let's label what we have so far. And the rest should be pretty easy to solve. What I have is that side A is 6.74. I have side B is 12. I have side C is 15. I have angle A is 26 degrees. So those are my 4 parts I've now found. True or false? I now have an angle and its opposite side. Yeah, I do. I've got an angle and its opposite side. So if I have an angle on its opposite side, what can I use now to find the other stuff? Law of sines, right? Yep. So let's set that up. Sine of what over what? Sine of 26 over 6.74. Sine of A over A equals. This is an important part, folks. At this point, choose to work with the smaller angle. Okay? Which is the smaller angle? Is the smaller angle going to be angle B or angle C? Look at their sides. Angle B is going to be smaller because it's got a smaller side. See that? Find the smaller angle first. Sine of angle B over 12. This is what we did the other day. I'll make this sine of 26 into a decimal. Sine of 26. I've got 0.4384. 0.4384 divided by 6.74 is equal to sine of B divided by 12. So to solve for sine of B, I multiply both sides by 12. If we multiply this 12 over there, I'll get that thing divided by 6.74. Multiply it by 12. And so I get 0.78048 is equal to the sine of B. 0.78048 is equal to the sine of B. So I go up here. And do you remember, if I'm trying to find an angle, what do I press on my calculator? I don't press sine, I press second sine. 0.78048. And I get 51.3. How do I find angle C? They all add to 180. $102.97. Good. Okay, let's do one more. We're not going to do the area of the triangle. Do that on other years where we have more time. All right. Which is the side that you should start by finding first? Side C. So which formula are you going to use? 1, 2, or 3? 3. Go ahead, take 2 minutes, see if you could come up with side C by using that bottom formula. I'm going to pause the video. Okay, as you worked, I'm going to now bring this back up and see if you got what you should have. You should have here C squared is equal to 4 squared plus 3 squared minus 2 times 3 times 4 times the cosine of 140 degrees. Again, I think all the calculators that we use up here should be able to have these plugged in. 4 squared plus 3 squared minus 2 times 3 times 4 times the cosine of 140. And you should square root your answer, and you should get 6.55. Can anybody confirm that they got the same thing? Good. I want to look at that 6.59 before I continue. 6.59, that's bigger than 4 and bigger than 3. Should it be bigger 4 than bigger than 3? I only got one angle though. Is it possible for this triangle to have more than one obtuse angle? Is it possible for these other angles to be bigger than 140? No way. Would you agree it can only have one obtuse angle? This is definitely the largest angle, and it's got the largest side. So I'm good to go there. Great. Now that I've gone ahead and solved for that, I now have an angle on its opposite side, which means I can use what? Law of sines. Sine of 140 divided by 6.59 is equal to, I told you, which angle do we go for first, the bigger one or the smaller one? Go for the smaller one. Is that going to be angle A or angle B? Yeah, angle B. So we go sine of B over 3. And we've now done it a couple times. Can I just show you how to save a little bit of time here? To solve for sine of B, we're just going to multiply both sides by what? Just by 3, right? So if you just type in 3 sine of 140 divided by 6.59, you can see that on this side you're going to get 0.2926 is equal to the sine of B. What do I press to find that angle? Second sine of that, and I get 17.01. B is equal to 17.01 degrees. And I got 180 minus 140 minus 17.01, and I get 22.99. So those are the two basic examples. That's all we really need to do. I do just want to make a disclaimer. Some people are watching this video who are maybe absent today, but believe it or not, other people around the world watch videos. Folks, I just showed two examples of the law of cosines where you are, in fact, just given an angle. Obviously, there are situations where you have side, side, side. I did not show those examples. And the reason why we choose the angle opposite the shorter side, that's something that comes up in other situations. So please just note that there's more depth to this than what we've gone through right now. So have a good day.